Hey guys, this is Professor Janacek, and I want to talk about differentials. Now, in calculus, when we mention a differential, we are not talking about the drivetrain of a vehicle. Instead, we are talking about a small change. Let's take a look. We'll let f be differentiable on an interval containing x. A small change in x is denoted by the differential dx. The corresponding change in f is approximated by the differential dy, which is equal to f prime of x dx, where y is equal to f of x. Let's see what we mean here. So if you want to take a look at the change in x, you've probably seen the notation delta x, where we're using the uppercase Greek letter delta to mean change in. Turns out that this is equal to our differential dx for small changes in x. We can look at the same sort of idea for y. The change in y we could denote as delta y. But notice this is the difference of our functions. Since y is equal to f of x, I could write this as f of x plus delta x minus f of x. Remember, this is a change in our y values, meaning a change in our functions, and that's why we use subtraction here. Now, as long as we're dealing with small changes in x, we can write this as f of x plus dx minus f of x. Again, this is only for small changes in x. But it turns out that we can say this is approximately dy, which, if you recall, the notation dy is f prime of x dx. Notice this is an approximate change in y. So as long as the changes are small, delta x is equal to dx. However, delta y is only approximately equal to dy. Now, it turns out we can also consider limits here. If we take the limit as delta x goes to 0, meaning the changes in x are very small, take the limit of delta y over delta x, what we end up getting is dy over dx. This comes into play when we look at integrals. Enjoy!